I'm getting fat, bruh. It's not a good thing, bruh. Yo, gyms need to open back up again, bruh. I can't take it no more. Your boy out here still a good swell. You wanna see up top? Hello guys, what's up? How you guys doing today? Welcome to another day of Algebra 2 with Mr. R. Today we'll be learning about right triangles in trigonometry. I've told you guys about reference angles and things like that, but now I'm gonna teach you about right triangles, and then we're gonna kind of put it all together later on. Trust me, it's a whole bunch of work, but we're gonna get through it, all right? What I want to focus on today is something you guys know about. You guys have been introduced to this in geometry, I believe, and this is here is called your right triangle, okay? Now, you all know this is 90 degrees. A right triangle always has 90 degrees. And then you would know something like this. Hypotenuse, okay, you have adjacent, all right, and then you have opposite, all right? Now, it depends on where this is being held at. This point is called theta, right? This is the angle called theta, all right? Now, this angle, the reason why it's labeled like this for the time being is because that if I was looking at this point of view, at theta's point of view, the reason why they call this opposite because right here is opposite of theta, okay? And then right here is adjacent to theta. And then obviously the longest side is always called your hypotenuse. That's why. So this is why it's always looked at this fashion. It changes depending on where your angle is. So if your angle is here, this is your opposite. However, what if I was to draw your angle here? I told you angle here, right? And you have your right angle right here, all right? And I said, now your angle is here. Well, now this becomes your opposite, okay? This becomes your adjacent. And then this stays as the hypotenuse because the hypotenuse is always the longest side. All right, so it depends on where you're really at, to be honest with you, okay, of the angle. So you can see there's two different ways you could possibly look at this angle. And like I said, it's according to where the angle is located. All right, so what you have here, if you guys remember from geometry, you have this here is called Pythagorean Theorem, with actually Pythagorean, and then to be honest with you guys, theorem, yeah, it's a squared plus b squared equals c squared, correct? Whoa. Random fact of the day, guys. Just because we were just talking about the Pythagorean Theorem, I felt like it's a really cool random fact for you guys to understand this. And it's actually pronounced Pythagorean, all right? The maker, his name was, you guys know him as Pythagoras, but his name is pronounced Pythagoras. In Greek language, they pronounce their names very different. So the syllables and the different consonants and things like that, they give up a different name. For example, Socrates. You guys don't know who Socrates is yet. If you do, congratulations. But he's a very, very famous philosopher that influenced a lot of philosophical questions that come with Plato and Aristotle. And I'm probably saying Aristotle's name wrong, but I'm gonna figure out how to say his name right. But his name is Socrates. It's not Socrates. And another one, if you guys, whoever wants to be a doctor, who wants to go into the medical field, it's not Hippocrates, it's Hippocrates, all right? So these are very different names when it comes to pronouncing them in Greek language because America has really, what's the term I'm looking for? Oh, we think we're better than everybody. Yeah, so we've been pronouncing their names wrong for the longest time, for centuries now. Another name, actually, if you guys think of it, it's actually not a common name. I feel like it came from SpongeBob, to be honest with you. Barnabas, right? You guys heard of the name Barnabas? One day I may, you guys know my llama, his name is Bartholomew. Now I'm gonna get him a friend and I'm gonna name him Barnabas, but we're not gonna call him Barnabas. His name is actually pronounced Barnabas. All right, and it sounds weird, I know guys, but this is the random fact of the day, just for a little culture for you guys to understand that Greek culture, they pronounce their names differently. And I'll probably add up another set of names towards the end of the video just to say a bunch of Greek names correctly, which I don't know why that matters. But I'm gonna do it anyway, all right? Back to the lesson. Pythagorean Theorem, okay? This will apply to anything here which you wanna understand. But there's very, very simple not simple numbers. There are very important numbers and they're special numbers that you guys should understand when it comes to understanding the Pythagorean Theorem of this entire right triangle. If you're ever given the fact, because you're always given two opportunities to solve it, and either it's Pythagorean Theorem way, or you can solve it with the trigonometric functions, and we'll go over that shortly. All right, so you have these special numbers here. Special numbers here. You're gonna have the 3, 4, and 5 right triangle. All right, and then you're going to have the 5, 12, 13 triangle. Then you're going to have the 8, 15, 17 triangle. All right, and then you're going to have the 7, 24, and 25 triangle. These are all special numbers that are associated with the right triangle. All right, now there's some uncommon numbers that are going to be used as well, and these uncommon numbers, let me see, uncommon ones, these uncommon numbers here are going to be written as this. You're going to get 9, 40, and 41, all right, which is here. Okay, I'm running out of ink now. 9, 40, 41, okay, and then you're also going to get this one here, and then you're also going to get 11, 60, and 61, okay? These are all very important special numbers that you guys will get. So if you ever get a right triangle with these two numbers or whatever the case is, you know for a fact that it will at least help you out to memorize these numbers here, all right? And it'll help you out. Another thing is, these set of numbers here, they're also special numbers of doubles and triplets. So, dang, I didn't do that right. There we go. All right, so these numbers here, you can either multiply them by 2 or multiply them by 3, and they will give you a special double or triplet that you could still use. Okay, so if I multiply it by 2, this one would be 6, 8, 10. All right, if I multiply it by 3, you'll get 9, 12, 15. All right, this one here, you'll get 10, 24, 26. Right, this one here, you'll get 15, 36, and 39. Right, yeah, 39. Okay, like that. So these ones you can multiply by a whole number, a whole number here, and then you'll actually still be able to use them in the same special number fashion. All right, class. Now to continue with our lesson. When it comes to the right triangles and the trigonometric style, we're gonna go over these things called Sohcahtoa. All right. Now, Sohcahtoa, if you guys don't know it already, it stands for. It's a mnemonic device, and it's a memory charm. Wow, why am I saying it like it's Harry Potter?
Oblivion!
So it's a memory charm. All right, a memory charm which is supposed to help you understand it. So it's saying it in a way. So if you guys don't know what a mnemonic device, why did that sound like bubonic? Like the bubonic plague, which I feel like we're going through right now. Now back to Sohcahtoa. Sohcahtoa. Okay, now. Okay, so we know that this is opposite over hypotenuse, okay? And then we know this is adjacent over hypotenuse. All right, and then we know this one is opposite over adjacent. Okay, now, like I was saying before, my film got cut, guys. Sorry about that, in the middle of it. So I think I was explaining at this point here, all right, and I give you this angle theta here. From here is the opposite, from here is the hypotenuse, you know that, and then this is the adjacent side. Okay, okay. So if I wanted to solve for anything, you would be able to easily find what you're looking for now according to what's here. All right, now the first thing you're going to do, you're trying to figure out a simple way to kind of explain this. Let's say if I gave you the example, draw another one here. Okay, and if I gave you, I don't know, 34 degrees here, all right, right there, all right, and I said you have 6 right here, and then you have x. You don't know what you're trying to find for this, all right? So what you want to do, whenever you're solving for anything when it comes to these trigonometric functions, you always want to use what you're given when you're trying to find a value, all right? So we know we have, this is the opposite, right? Okay, this is hypotenuse, right? And then this is your adjacent side, right? Okay, so this is capital C, capital B, capital A. All right, so, wait, that was wrong. I think this is capital B here. Sorry. This is capital A. Aha, okay, so anyway, so what you want to solve for, we know we have 6 here is our adjacent side, and this is our opposite side, all right? So you want to look for the function here that's going to give you both, all right? Well, in this case, it's opposite over adjacent, so we're going to be using tangent, okay? So now when you're going to solve for this, you're going to use, over here, all right? So you're going to use tangent of your degree, which is 34 degrees, all right? Tangent 34 equals, all right, you're going to use opposite over adjacent, all right? So you're going to get x over 6, okay? Now, we solve like how we do any mathematical function, all right? Now, when you're trying to get rid of this, you're trying to isolate for this value here. You're trying to isolate for this value here. We're just going to multiply 6 by the entire function, all right? So these 6's cancel, all right? So now you're left with 6, all right, times tangent of 34 equals x. All right. Now, if you plug that into your calculator, hold on, okay, by the way, if you plug it into your calculator, make sure you're in degrees, not radians mode. If you're in radians mode, you're gonna get some random number. Okay, so make sure you're in degrees. All right. So when you plug this in to tangent, give me like 1 second. I'm gonna pause the video and then I'm gonna go ahead and do it on my calculator. All right. Welcome back to our regular schedule program. Here we go. When you plug this into your calculator, like I said, make sure it's in degrees, not radians. Once you plug in 6 tangent 34, you're gonna get 4.04, blah, 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 blah. It's like some other numbers or whatever the case is. If you wanna write all those numbers, that is fine. If you wanna round it, that is okay too. Just remember, if you're solving for your extra side here, which is your hypotenuse, being that there's no value there, you wanna keep that number as plain as possible. So you don't wanna round it. If you round it, you're not gonna get the most exact answer, all right? So, if you wanted to solve for hypotenuse, I have 2 choices. I can use either sine or cosine, all right? Or you can use, a squared plus b squared equals c squared. You can always use that function if you feel like it's easier, all right? So if you wanted to use sine, we'll go ahead and use sine. So we'll just say sine of 34, okay, equals opposite over hypotenuse. Now we know our opposite is 4.04, so it'll be 4.04 over, now our hypotenuse we'll just call little c. Okay, now you have to do 2 things now, all right? So what you're going to do, you're going to multiply this entire function by c, okay, to get this c done here and bring it over here. And then you're gonna divide, okay, you divide your sine 34 over here. You're gonna bring it all the way back over here, all right? So now, then you're gonna divide by sine of 34. This cancels, and then you're gonna have c equals 4.04 blah 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 over sine of 34. Okay, and then your answer should be, in a second I'm gonna show you. All right, once you get here, your answer should be 7.237, something like that. So you should get 7.237. If I'm wrong, I'll put it like right here in the video. If I'm right, I'm gonna put it right here in the video. All right, so this is what you should get from my calculations. Only because I probably did it too fast, and so now we know that the entire triangle now equals 4.04, and this would be 7.237 here. That's basically it. All right. Now, if I wanted to, all I need to do is then find the other angle that's equal to here. What is this angle equal? All right. So what is that angle? I don't know what that angle is. I want to find out what that angle equals, right? So just so you guys know, the entire measurement of a right triangle equals 180 degrees. All right. So therefore, you're gonna get 90, right, plus 34, all right, plus the angle, right, A at this point, right? The angle A equals 180. All right. So then, if I know that, I can just add these 2 up. Now, 90 plus 34 is 124, all right? So if you subtract 124 from 80, you should get 56, right? 56, so therefore angle A equals equals 56 degrees. Okay, so now I just solved an entire right triangle.
Tak, na astronomy, attack.